In this video, we're going to deal with integration by parts. Let me brief you a little bit with integration by parts. So let's say we have the integral of f of x times g of x dx. And when you let one of these functions to become u, you find that you can't find the derivative. For example, let's say you have e to the x times maybe ln of x dx. So you see, when we check for the derivative of ln of x, it's just 1 over x. So it can cancel e to the x. So here there is a need for you to use integration by parts. So in integration by parts, you will have function of different types, like the one with exponential, logarithmic, or maybe trigonometry. So in integration by parts, there is a word which is called LIATE. And LIATE, when you break it down, it means this one is logarithmic or natural log, and this one is inverse, and this one is just algebra like x or y, and this one is just trigonometry. This one is the exponential. So every time when you are trying to evaluate an integral that is associated with integration by parts, you need to write this with LIATE. This with LIATE will help you which function should be u if there are two. So let's say you're given x times arctangent of x. So following the weight LIATE, the first letter that comes between this one, here we see algebra, and here we see the inverse. So which means the one that qualifies to be u, it will be the one that has the inverse. So the formula for integration by parts says, if you have the integral of u times dv, this one will be equals to u v minus v du. So this is the formula that we're going to use throughout, and that word which is called LIATE. These two things are very important. So let's try to attempt some problems to see if we get it. Let's say this time you're given the integral of ln of x dx. So here you're gonna write LIATE somewhere in the paper, and you write your formula to be uv minus v du. So here it's clear that we have logarithmic in this integral. So we're gonna say let u to be equals to ln of x. So for integration by parts, we're gonna find the value of v and the value of du. So after letting u to become ln x, you're gonna say du is equals to, let's say du dx. What is du dx? What is the derivative of ln x? Is 1 over x. So you need to make du here to become the subject. So you'll have du is equals to 1 over x times dx. So now you need to find v, but you'll have to find dv first. So dv will be equals to, dv is everything that remains after taking u. So you can see that when you eliminate ln x here, we pretend like we don't see it. We will remain with dx. So we need to take the integral of dv. So the integral of dv will be equals to v, and the integral of dx will be equals to x. So we need to take this information which is here and substitute it into this formula. So let me create some space. So this one will be equals to, we are going to use this formula. Our u will be ln x, and our v will be equals to x, which is here, minus the integral. What's v? V is x. So du will be equals to 1 over x dx. So now we'll have ln x times x minus 1 over x times x. It is just dx. So we'll have ln of x times x. What is the integral of dx? Is x. So we're going to put the concept of integration. So that is the integral of ln x. Let's try another example. Let's say this time you're given the integral of x squared times e to the x dx. So when you go somewhere and you write that word LIATE, let me just write it here. You write LIATE here. Which one between these two functions should be u? The first function is algebra and the one is exponential. So meaning to say that we're gonna say let u equals to the one with algebra because algebra comes first. So we're gonna say let u equals to x squared. So du is equals to 2x times dx. And you need to find dv. dv will be equals to e to the x times dx. So v will be equals to, the integral of e to the x will be equals to e to the x. So now we need to substitute this information into this formula. So the integral of x squared e to the x dx will be equals to uv. What is u? U is equals to x squared, and v will be equals to e to the x minus the integral of v du. So v will be equals to e to the x, and du is just 2x dx. So the integral of x squared e to the x times dx will be equals to x squared e to the x minus, here we see a constant, so we're going to take it out, the integral of e to the x times x dx. So even there, we are going to use the same procedure. Between these two terms which are here, which one should be u? So this one is exponential. So exponential in the word LIATE is the last one. So we're going to say let u equals to the algebra, which is just x. So du dx will be equals to 1. Therefore, du will be equals to dx, and dv will be equals to e to the x times dx. So you need to find v. Take the integral. dv, the integral of dv will be equals to v, and the integral of e to the x is e to the x. So again, here you're going to apply the integration by parts formula, which says uv minus v du. It's going to become the integral of x squared e to the x times dx, which is equals to x squared e to the x minus 2 into, here we apply the formula. What is v? What is u? U is equals to x, and v is equals to e to the x minus the integral of v is equals to e to the x, and du is equals to dx. So we'll have that the integral of x squared e to the x times dx will be equals to x squared e to the x minus 2 into ex times e to the x minus the integral of e to the x is equals to e to the x. You add the concept of integration. So now it's time for you to simplify. So you'll have x squared times e to the x minus 2 times x e to the x will become 2x e to the x, and minus 2 times e to the x will become positive 2 e to the x plus c. So this one is the integral to this question. Hopefully now you get it. So let's try another one, and this one is for you. So I'm not going to remove this box. So even when you're writing, you're going to have LIATE in the box. It's gonna guide you, even the formula. So let's say this time you're given the integral of e to the x times the cosine of 3x dx. Go ahead and try to attempt this one. So in the way LIATE, we have exponential here, even the trigonometry. So the one that comes first is trigonometry. So we're gonna let u to be equals to the cosine of 3x, and du dx of cosine of 3x will be equals to minus sine 3x multiplied by 3, which is the derivative of the angle, and dv will be equals to e to the x dx. So the integral of v will be equals to e to the x, and the formula says uv minus v du, the integral of v du. So now let's write the left hand side, it's very important. So I'll have e to the x times the cosine of 3x dx, which is equals to, what is u? U is cosine of 3x, and v is e to the x minus the integral of, what is v, e to the x times minus sine of 3x, which is here, times 3 dx. So to keep the left hand side, we'll have the integral of e to the x times cosine of 3x dx, which is equals to, here we'll have a positive, then we'll take the 3 outside. But you can see that here still we need to apply the integration by parts again, because we are not looking for the integral of e to the x sine 3x. We are looking for the integral of e to the x cosine of 3x. So we need to apply the the integration by parts again. So we're going to have the cosine of 3x times e to the x plus. Now we can take these 3 outside. Here we'll apply the integration by parts formula. So now, between these two terms, e to the x and sine 3x, which one should be u? So in the way LIATE, trigonometry is the one that comes first. So we're going to say, let u equals to sine 3x. So du will be equals to the cosine of 3x times 3. And dv will be equals to e to the x dx. So you need to find v. So this one will become e to the x. So now we need to apply integration by pass formula here. So u will become sine 3x and v will be e to the x minus the integral of v du, and our v will be e to the x, and du is equals to 3. We can take this 3 outside, the cosine of 3x dx. So now we see that we have e to the x cosine of 3x dx even on the right hand side. So we are close to the answer. Let's just finish the problem by simplifying. So we'll have the integral of e to the x times cosine of 3x dx, which is equals to e to the x, the cosine of 3x, and 3 times these terms which are here. You will have plus 3 sine 3x e to the x. 3 times the integral of e to the x times cosine of 3x dx will be equals to minus 3 times 3 is 9. We'll have the integral of e to the x times the cosine of 3x dx. So now, what we can do is to take this minus 9, the integral of e to the x cosine of 3x, to the left hand side. So this one will become positive. So we'll have 9, the integral of e to the x cosine of 3x, plus the integral of e to the x times cosine of 3x dx. Even here there is dx, which is equals to e to the x, the cosine of 3x plus 3 sine x, 3 sine 3x e to the x, plus the concept of integration. So 9 plus 1 is equals to 10, the integral of e to the x cosine of 3x dx, which is equals to e to the x times cosine of 3x plus c. So remember, we are not looking for the integral of 10 integral of e to the x times cosine of 3x. We are looking for the integral of what is written here. So we need to divide by 10 throughout. So divide by 10 will have divide by 10 divided by 10 divided by 10 divided by 10. So we'll have the integral of e to the x times cosine of 3x dx, which is equals to e to the x, the cosine of 3x over 10 plus 3 sine 3x e to the x divided by 10. And c divided by 10 is a constant. So you're going to add c here. So if you are here in this point, you will be done to integrate this type of integral. So I'm hopeful now you understand. You need to keep the left hand side when you have something like this. Or always when you integrate by integration by parts, you must keep the left hand side. So let's try another one. So let's say this time you're given, let me just divide some space here. So let's say this time you're given the integral of x squared minus 2x plus 1 times e to the x. Should be e to the 2x. So you need to draw a box that will help you to make some information. So first of all, you write the word LIATE. So between these two functions which are here, which one should come first? We have an exponent and we have the algebra here. So we see that the algebra is the one that should come first. So we're going to say that let u equals to x squared minus 2x plus 1. And du will be equals to 2x minus 2. So dv will be equals to e to the 2x dx. So the integral of dv will be equals to, the integral of e to the x is e to the 2x divided by 2. So the formula for integration by parts says u dv minus is equals to uv minus v du. So now let's substitute this information into the integral. So it's very important to keep the left hand side. E to the 2x dx. So what is u? U is equals to x squared minus 2x plus 1. Plus 1. And v will be equals to e to the 2x divided by 2 minus the integral of v du. V is equals to e to the 2x divided by 2, and du is equals to 2x minus 2. So if we want, we can take out a common factor 2. So I'll have 2 into x minus 1 dx. So clearly can see that this 2 and this 2 will cancel each other. So we'll have x squared 2 plus 1 to the power, times e to the 2x dx, which is equals to 1 over 2 e to the 2x times x squared minus 2x plus 1 minus the integral of e to the 2x times x minus 1 dx. So now, here we need to apply the integration by parts again. So the procedure is still the same. Between these two terms, which one should be u? So x minus 1 is the algebra, is the one that comes first in the word LIATE. So we're going to say let u equals to x minus 1. And u will be equals to dx, because the derivative of x is equals to just 1. And you need to find v. So dv is everything that remains after taking du. So we'll have e to the 2x dx. So v will be equals to 1 over 2 e to the 2x. So I'll have the integral of x squared minus 2x plus 1 times e to the 2x dx, which is equals to 1 over 2 e to the 2x x squared minus 2x plus 1 minus, now we need to apply the formula. U is equals to x minus 1 and v is equals to 1 over 2 e to the 2x minus the integral again. What is v? V is 1 over 2 times e to the 2x and du is equals to dx. So we'll have the integral of the left hand side, which is the question there. E to the 2x x squared minus 2x plus 1 into x minus 1 1 over 2 e to the 2x minus the integral of e to the 2x is equals to e to the 2x times 2. So this is equals to, this implies that the integral of the left hand side is equals to 1 over 2 e to the 2x minus, times x squared minus 2x plus 1. So here when we distribute the negative, we'll have x minus 1. Let me just do well. We'll have 1 over 2 e to the 2x x minus 1. And when we distribute the negative here, we'll have a positive 1 over 2 times 1 over 2 is 1 over 4 e to the 2x plus c. So this one it is the integral of this question here. I believe now you're getting it. Let's do another one. So let's say this time you're given the integral of the arc tan of y dy. Go ahead and try to attempt this one. So you remember you need to have a weight LIATE. So here we see algebra to be x to the power of 0 and the inverse. Which one between these two terms should be the u? So the inverse is the first one. So we're gonna say let u to be equals to the arc tan of y. So du is equals to the arctangent of y, the derivative of arctangent of y will be equals to 1 over 1 plus y squared dy. And dv will be equals to 1, which is dx, dy. So I'll have v to be equals to y. And the formula for integration by parts says uv minus v du. So this implies that the integral of arctan of y dy is equals to u is equals to arctangent of y and v is equals to y here minus the integral of v du. V is y and du is 1 plus y squared dy. So this implies that the integral of the arctangent of y is equals to y arctangent of y minus. So here we are not going to use integration by parts because we can see that when we derivate, we take the derivative of 1 over y, 1 plus y squared, we will have 2y, and that 2y will cancel y here. So we're gonna use u substitution. So let's draw another box here so that we can do our work. So if we say that the integral of y plus y squared dy, let u to be equals to 1 plus y squared. So du dy is equals to 2y. So where there is dy, you are going to put 2y. So dy will be equals to du over 2y. So when substitute the information here, we're going to have the y over 1 plus y squared is equals to u. And dy is equals to du over 2y. So 2y, the y with the coefficient 2 will cancel this one. So we'll have the integral of arctangent of y dy, which is equals to y arctangent of y minus 1 over 2, the integral of 1 over u du, which is equals to arctangent, y times arctangent of y minus 1 over 2. The integral of 1 over u is equals to the ln of the absolute value of u. and plus C. So are we done with the problem? The answer is no. We need to write everything in terms of y. So where there is u, we need to put y. So this one will be y, the arctangent of y minus 1 over 2, the ln of, what is u? U is the arctangent of y. No, it should not be arctangent of y because this one is not in the other side, but it's coming from this side. So we'll have that our u is equals to 1 plus y squared plus c. So this is the answer to this problem. And remember, if you don't get it, feel free to rewind the video, rewind until you understand. And if you see some mistakes, feel free to comment on the comment section, then we'll fix that. Of sine x ln of x dx. Go ahead and try to attempt this one. So let me just make some information here. So following the weight LIATE, L is the first letter. So we're gonna say let u equals to ln x. But we see that ln x is inside the sine x. How can we simplify this problem? So what I can do is to say e to the u is equals to e to the power ln u and ln x. And remember, the base for e is e. For ln is e. So they will cancel each other. So I have that x is equals to e to the u. So let's substitute, let's take the derivative of dx. So dx will be equals to e to the u times du. So our whole problem will change this time. Because if it is like this, we cannot apply integration by parts. So we have to simplify. So we'll have sine of, what is ln x? Ln x is u. And dx is e to the u times du. So now our problem is simplified. Now we can apply the integration by parts. But let's agree on this one. The formula for integration by parts is u v minus v du. So because I can see that if we keep on using uv and v du, it's gonna confuse us. Let's let this u to become maybe a variable z. So we're gonna have z v minus v dz. So following the word LIATE, even in this one, LIATE says the one that we should let to be u between a trigonometry and an exponential, it should be a trigonometry. So we're going to say let z now is our u, to be equals to sine u. So dz is equals to cosine of u times it should be times du. So dv will be equals to e to the u times du. So v will be equals to e to the u. So let's substitute into the formula. Z is equals to sine u and v is equals to e to the u minus the integral of v is equals to e to the u and dz is equals to cosine of u times du. So now we see that again we have the integral of e to the u cosine of u. If we keep on integrating, we might not, if we leave it like this, we might not get the integral of sine of u e to the u du. So what you need to do here is to integrate this one. So even on this one, we're going to apply integration by parts. So let's draw a box for information. So between exponential and trigonometry, the one that should be z, because z is equals to u this time, it should be a trigonometry. So we're going to say z is equals to cosine of u and dz is equals to minus sine of u du. So how about dv? dv is e to the u times du. So v will be equals to e to the u. So we're going to apply this integration by parts again on this one. So I have the integral of sine of u times e to the u du, which is equals to sine of u e to the u minus, let's apply the integration by parts form. So z is equals to the cosine of u and v is equals to e to the u minus the integral of v du. V is equals to e to the u times, and dz is equals to minus sine of u and du. So this minus and this one will make everything to become positive. So I'll have the integral of sine u e to the u du, which is equals to sine of u e to the u, and when we distribute the negative there, we'll have minus the cosine of u e to the u. Even here we'll have minus, so it will be minus the integral of e to the u, the sine of u du. So we need to get the integral of e to the u, e to the u sine u du. So we can take this one to the left hand side. So we'll have 2 sine u e to the u du, which is equals to sine u e to the u minus cosine of u e to the u plus c. So all we need to do is to divide everything by 2. So we're going to say divide by 2, divide by 2, divide by 2, divide by 2. So the integral of this one will be sine u e to the u du. So here you can see that we have a common factor e to the u over 2. So we're going to say e to the u over 2 divided by 2 into sine u minus cosine of u, and c over 2 is equals to c. So this is the integral of sine u e to the u du. But the question is, are we done? And the answer is no. We are not yet done, because we need to write everything in in terms of x, like the way we find the question. So let's see if the left hand side was correct. So here we'll have the integral of sine of, what is u? We said that u is ln x. And what is du? So going back here, we'll divide e to the u by e to the u. So du will become dx over e to the u. And e to the u, what we know is that e to the u is like this one. So the base here is equals to e. So this one and this one will cancel each other. So here we'll have that this one is erase x, and x is equals to e to the u. So here everything here that we're gonna do, because there is also dx. Let me just try to write it well so that I don't confuse you. So what's happening here, we're gonna substitute what it is on the left hand side. So we're gonna have the integral of sine, and u is equals to the ln of x and times e to the u, and du is equals to dx over e to the u. So this one and this one will cancel each other, and e to the u, as I said from here, e to the u is equals to e ln x, and the base is x here. So this one will cancel this one, so we'll be left with x. So our answer here will become x divided by 2 sine, what is u is equals to ln x, minus cosine of ln of x plus the concept of integration. If you know any other method that will make this problem to be simple, feel free to comment on the comment section, because this problem, it may look more involving. So this one will give us that This is the integral of sine of ln x dx, which is here, which is equals to x over 2 sine of ln x minus cosine of ln x plus c. So this time, let's do the last one. So let's say you're given the integral of y squared ln of y dy. Go ahead and try to attempt this one. So we're going to use the word LIATE to see which one should be you. So LIATE says if we have a natural logarithmic and if you have and the algebra, you should start by letting u to be the logarithmic. So you're gonna say du is equals to 1 over y dy. So dv will be equals to y squared dy. So we take the integral to find v. So the integral of this, we're gonna apply the power rule, which is y over 3, y to the power 3 divided by 3. So the formula for integration by parts is uv minus v du. I'm sorry about that. So here we're gonna say that this is the integral of y squared ln y dy, which is equals to what is u is equals to ln y, and v is equals to y cubed over 3 minus the integral of v du. V is equals to 1 over 3 y cubed times du is equals to 1 over y dy. So this one will become y squared ln y dy, which is equals to 1 over 3 y cubed ln y minus 1 over 3 y over 3 divided by y is y squared dy. And the integral of y squared ln y is equals to y over 3 y cubed ln y minus 1 over 3. When we apply the power rule here, we'll have that this one will become y cubed over 3. We add a constant of integration. So this one y cubed ln y dy will be equals to 1 over 3 y cubed ln y. So 1 over 3 times 1 over 3 is 1 over 9 y cubed plus c. So this one is the integral of this problem. If you have not yet subscribed to the channel, feel free to subscribe, and if there is something that I did and that thing is a mistake, comment on the section below so that you can fix it, because I admit it, I'm also a human being. So if the video was so helpful to you, you can click the like button and share it to someone. Thank you very much for taking your time and watch this video.